Hi math students, just part two of reviewing the process of factorization of quadratics. We got into this problem G with looking into that factorization process via the splitsies method, okay, where we had to consider the first and the last term. So we're looking at the coefficient of the first term multiplied by the constant of the last term, thinking about two factors that you could use to add to give the middle term here, which is the one that we need to split up. Okay, and we figured out that the two factors of 10 were 2 and 5, which added to give 7. So we know that this middle term gets split up, okay, into 2x and 5x. Then we moved into the process of splitting it down the middle and factorizing the first half and the second half. And beautifully, we get a common factor of x plus 2 for both of those sides, which we then can fully factorize the quadratic. Have a go at, pause the video and have a go at examples H and I. And we'll see how you went. All right, how did you go? Talking through this question H, hopefully you took the coefficient of 1 to the x squared multiplied by the negative 28, and then had to think about which factors of negative 28 add to give this coefficient in the middle here of negative 3. So when I think about it, hopefully you came up with negative 7 and 4 multiplied to give negative 28, and negative 7 when added to 4 gives negative 3. So this tells us that our middle term here, negative 3x, that's the thing that will get split up into what I've just discovered, into negative 7x plus 4x. All right, then going through that process, splitting it in half, factorizing the first half, common factor of x, factorizing the second half, common factor of 4. Once I've completed that partial factorization process here, then you should be able to see that you get a common factor of x take 7 in brackets. So that's your bracketed factor, which we then factorize and we pull it out the front. And what we're left with in brackets is the x plus 4. Moving down to the next question. This one was using bigger numbers in front of the x and that constant at the end there, which you could multiply together and think about factors there of 350 that add to give negative 45. But hopefully what you did notice was if I look at each of these three terms, this has a highest common factor of 5. So I can actually take out a highest common factor before I worry about this splitsies factorization process, and it makes it a lot easier to deal with. So from there, just looking at factorizing what's inside brackets here, if I take the 1 in front of that x now and multiply it by the 14 constant term at the end there, I get 14. So I'm thinking about what factors of 14 add to give negative 9, the negative 9 in the middle here. So when I think carefully about that, I get negative 7 and negative 2 multiplied to give 14. They also add to give negative 9. So I tell myself that negative 9x gets split up into negative 7x and negative 2x, which gives me my next line. I then want to factorize each half. Okay, so first half, highest common factor of x, remove that out, I get x takes 7. This side, highest common factor of negative 2, bring that out, and I'm left with x minus 7, which is perfect. So now I've got a common bracketed factor of x minus 7. And then finally, I can remove that out, the front, and I'm left with my x minus 2 in the other bracket, the remainder bracket. So fully factorized, this quadratic I started up with is 5 outside of x minus 7, x minus 2. Okay, I'd like you to have a go at the last example J there. Now this one, it would be like a complex familiar type question because you're incorporating your skills of dealing with simplifying algebraic fractions as well as factorizing quadratics. How fun is that? So have a look at the numerators and denominators and see what factorization methods you might need. So if I look at this top one over here, x squared minus 9, well, that looks to me like a difference of 2 squares. If I look at the bottom one here, I can't really spot any square numbers, so it must be like that Splitsies factorization technique that I need to incorporate to factorize that. Moving over to the top of the right-hand fraction, again, can't spot any patterns there, so I'm going to have to go to my Splitsies factorization method, and then easy as factorization on the bottom over here, looks like a highest common factor. All right, press pause, give it a go, and we'll check back in to see how you went. Okay, let's check in with how you went. So for that top one, difference of 2 squares, we've got x squared minus 3 squared, which fits nicely into that pattern, giving us x plus 3, x minus 3 in brackets. Considering the denominator, that negative 2x down the bottom in the middle here, that would get split up into negative 5x plus 3x, considering that we have 1 multiplied by minus 15 as our multiple. So factors of negative 15 are negative 5 and positive 3 that also add to give the negative 2 here. Okay, so I can split that up. This eventually gets factorized. The first half, x is the highest common factor. Second half, 3 is the highest common factor. So factorizing it nicely into x minus 3, x plus 3. If we move across to the right-hand side fraction, the top there I had to factorize again using the Splitsies method. So I want to come up with how to split up this negative 4x, considering that my first term is 1 multiplied by the constant term is negative 5. So what 2 factors of negative 5 add to give negative 4? Well, that's negative 5 plus 1 give negative 4. So I know that this middle term gets split up into the negative 5x plus x. If I move to factorize each half, I've got x on this side as the highest common factor, 1 on this side as the highest common factor. Got that beautiful common bracketed factor popping in there. And if I remove that out from both terms, I'm left with the x plus 1 in brackets. Okay, and down the bottom, highest common factor of 2, which I can take out. And then it's just a matter of having a look for any common factors in my fractions that I can cancel out. So here I can see I've got an x plus 3 and an x plus 3 which cancel. Cross cancellation, that x minus 3 will cancel nicely with that x minus 3. I got an x minus 5 that's going to cancel with an x minus 5. And lo and behold, I'm left with my x plus 1 on 2. All right. We're going to have a look at further factorizing quadratics using surds next, so stay tuned.